So from I shouldn't say from yesterday. That's an automatic badness. From Monday.
Restart.
From Monday. We just did. Start it over? Oh, nah, we'll let it slide. It's okay to make mistakes. Yeah. It's okay. It's okay to show that you're vulnerable. Okay? All right. Find me the inverse of
Don't look at me like that when he says that, bro.
First step.
Switch X and Y.
Put in Y for X.
Yeah.
Yep. Make M of X be Y in this case. Step 2. Switch X and Y. Third step.
Yes. So add A.
Solve for, so what are we solving for?
Y.
Y. Okay, so adding 84. Then
Divide by 17.
okay. Last step.
Right.
As what?
Oh, change it.
M of X.
M of -1.
So the inverse of M
Oh.
is the fifth root of X plus 84 all divided by 7. Yes?
Yep.
Okay. Good time. Question. All right. Here we go.
I'll just look at the whole page.
Probably. Okay. So let's play a game. The game is function, not a function. Okay? Sweeping the nation. Okay? It's the most popular game at the most popular high schools in the most popular subjects of the most popular floor in all of the land.
That's kind of cool. Maybe Fortnite.
Even better than Fortnite. Yep. Yep. So there's 2 rules to function, not a function. The first rule you already know. The first rule is if I'm looking at the picture of a relation, so the graph, how do I tell if based off of that picture, what I'm looking at, how do I tell if that's a function or not?
It's like consistent. Like if it's not like,
Okay. I have no idea what you said, but yeah, we'll go with it.
like, you know, like if it's like consistent, like,
As well.
Like, is there a test that we could do?
vertical line test.
We can do the vertical line test. Okay. Yeah. Okay. So the first rule is the vertical line test. Okay. Now, the vertical line test tells me what I'm looking at, if that is or isn't a function, and only what I'm looking at. And you've done that before. You've taken a vertical line, remember vertical, up and down, and you slide it left and right across your graph. Okay? And what does the vertical line test, or what is the vertical line test? I think is a better way of saying it.
Checking to see if there's 2 points of the same, like, there's 2.
I understand what you're saying on this one.
Yeah.
If my relation touches in 2 points, then what? Not a function. So it's got to only touch in one point all the way across for it to be a function.
Right.
Okay? I like it. Everybody agree with that? Okay. Vertical line test, you've seen it for a couple of years. Okay. Rule number 2. Now, I'm going to add another test. What do you think this test is going to be?
The horizontal line test.
This is going to be the horizontal line test. Okay? So now we're going to have what's called the horizontal line test. And the horizontal line test tells me if the inverse of what I'm looking at is or isn't a function. Because remember, to find an inverse, we switch the x and the y. So vertical becomes horizontal, and so we check that. Okay? So vertical line test tells me if what I'm looking at is or isn't. Horizontal line test tells me if the inverse is or isn't. Okay? Now the reason that we have to do this is because if a graph passes both of the tests, then we call that function a one-to-one function. That function then is called a one-to-one function. Now, I will be 198% honest with you. The only reason that you are learning about one-to-one functions is because there is a question on your final that asks, is this function one-to-one? Okay? So this is a question on your final. Okay? So in order to see if a function is one-to-one or not, you have to perform the vertical line test and you have to perform the horizontal line test.
Which means we're going to have to figure out the inverse.
No.
Right?
No. Which means you got to figure out the graph. Because once you have the graph, then you can do vertical and horizontal line tests. You don't have to figure out. We will today, and I can't remember if that's part of the function or I think it is. Determine if it's one-to-one and if so find the function, or find the inverse kind of thing. But that's the same as what Monday was. You know what I mean? That's change it to equation, switch x and y, solve for y, flip it back. Okay? All right. So on each question, or if this were like a one-to-one type of thing, I would want you to first, you gotta sketch the graph. You gotta sketch the graph first. Second, you gotta determine if what you're looking at is a function. Because if it's one-to-one, then what you're looking at had better be a function too. Third, you gotta do inverse function. Is that a function, or is it an inverse function? And then, is it one-to-one, and if so, then what is that inverse function? Okay? So, there are a couple of different ways to sketch the graph. Okay? So first, you can make a T-chart. How do we make T-charts?
Pick T, and then you do an input and output.
Which one do you, like, how do you come up with an input? How do you come up with an output?
The X's are the inputs, Y is the output.
Okay. So what do I do with the T-chart? Just randomly put numbers in all columns?
You get what the X value.
So I get to pick the X values, and then what?
Whatever you get put into the function.
Put those into the function, get the Y values. Okay. Then I would plot those points. Okay. And then that would give me the sketch of my graph. Okay. That's the first way. That's probably the way that you're going to most use, which is why I said it first. Second method that you could use is you could use a graphing utility, like a graphing calculator, or Desmos, or that stuff. The The downfall with that is you don't get to use decimals on your line. Okay? So but that's an option too. Okay? Third way is you can use logic. Okay? You can think back to when we were talking about end behavior. What do I know about 2x squared?
Put it on the same direction.
Both ends are going to go in the same direction, up or down? Up, right? Because its lead coefficient is positive. Okay? So I can use that kind of a stuff. Okay? Last, you can use your knowledge of prior stuff. You know, if it's an absolute value graph, which we'll have a little bit, if it's a quadratic graph like this, if it's a cubic, all those different things that you've done in graph before. Okay? So here is, since this is the first one, I'm going to just do it this way. Okay? So here is the graph. This is the actual graph of f of x equals 2x squared. Okay? So there's my graph. You might want to sketch that down. My question to you is this. Is what I'm looking at a function?
No. Yes. No. Yes.
Yeah, it's
How do I test it?
vertical line.
That one is tested with the vertical line test. So I take my vertical line and I start on either side. I drag it all the way across, making sure it only ever touches in one location. Yep. Okay. So that one works, checks out. Yes, this is past the vertical. Is the inverse of this a function?
No.
Why not?
Doesn't pass.
Does not pass the horizontal line test. If I take my horizontal line, shabam, there it is, and it fails there and there. Okay. So no, this does not. So is this function one-to-one? No, it is not.
What would the inverse look like? On the graph?
Of this one, it would be a, let's see,
Wait, so that would pass it?
That wouldn't be a function. It passes an inverse, but not a function.
the green one, what I'm looking at is not a function, but the inverse is a function.
Wait, what?
So if I'm looking at the green one, right, now, as my function, okay, the green one is the inverse of the red one, okay? But if I start with the green one doesn't pass my vertical line test,
Perfect.
right? Right? But it does pass my horizontal line.
Yeah.
With me?
What does that mean?
It's still not one-to-one. Because it's got to pass both
Oh,
in order
so
for it to
even
be
the-
one-to-one.
So even the inverse has to pass both.
No, well, if the inverse passes both, then the function's going to pass both.
Right?
I think you just confused yourself.
Well, I thought, I don't know. Sir, yeah. That's the other. Oh. God,
All right, here we go. So, hold on 1 second. All right, so the first thing we got to do is we got to sketch our graph.
Find out. Look, this one works.
What's our graph going to look like?
It's going to be opposite directions with positive for the right side. Like going up to the right side.
Okay, all right. But we got to be a little more specific than that. You know what I mean?
So you're going to have a little hump there.
Go with yours, Luca. How do you know that it crosses the y-axis at -2? Because
Like why that's supposed to be.
it's not like y equals mx plus b. Because it's not y equals mx, it's y equals x cubed. So how do you know that it crosses at -2? That it's got a y-intercept of -2.
So that's the formula that tells that -2 back there. Leave it fast and then
Help them out. They're struggling up here. The y-intercept is actually -2. Your logic behind it is completely false.
Well, he said that. I didn't say that.
That's what you were thinking.
No.
So here's my question. Why is the y-intercept, or how do I know that the y-intercept is at 0, -2?
Because when you put 0 in for x, -2 is what's left.
That's what
When you
That's what I
plug
was
in 0,
that's what I was
the
saying.
outcome is -2.
That's what I was
No, it wasn't.
I didn't translate it for you.
Okay? So now we got to figure out what the rest of these look like. So what do we have to do?
Plug in.
Plug in numbers. Okay? So
1 cubed is 1. -2 is 1. No, -1. Go ahead. Probably the second smartest one in the room.
keep going.
-2. And then that one is 8, I think, right?
Mhm.
-2 is 6. Oh, that's a good jump. -2 is negative. It's a -1.
-1.
-2 is -8. -2 is -10. See? And it passes because nobody crosses that one off.
So we good there?
Uh-huh.
Okay. So there's my sketch. Is it a function? Actually, here I'll give it. Okay, so that was my sketch. Down here, I've got it actually graphed out. Okay?
Maybe it's not a function.
So let's look at the actual one, because then it's not a sketch. Okay? Function, not a function.
Honestly, it's too small.
function.
Function? Yeah, never cross. It doesn't ever, like, come back on itself, right? Okay? So I would say that that's a function.
But we talked about the word about that. And the second person.
Okay? Horizontal line test. Now,
Yo.
pass,
Pass.
For sure.
pass.
So
So what does that mean?
that means
And it's one, it's a one-to-one function right there. Ladies and gentlemen. You see it.
because they're fast.
Okay. So now it's 1-to-1. So now let's find what the inverse is. Okay? So again, we started with f of x is x cubed minus 2.
We're going to substitute that y in for fx.
Okay?
Let's switch those positions around. Get rid of that -2, add 2. We're going to cube root that thing.
Inverse of F?
Inverse of that. Inverse of. Yeah, where is Iris?
It was 8 o'clock.
Is Noah here?
Okay. Love it.
You can test me on this right now.
Let's go. Make it happen. There it is.
Oh.
Determine if it's 1 to 1.
Oh, wait.
What do we got for a picture of the graph?
It's just like a U.
What?
No,
No, it's just like,
Yeah, it gives
It's
you
like
a
it's
straight line?
it's access and then.
No, it's a V.
Just a straight
It's a
line?
linear.
It's like y
X
y goes
minus
MX plus
two.
B. Like I said before.
Should be a V. Because it's an
See, that's why I
absolute
said
value.
Value.
Isn't that what I just said? I
You
said
said
V.
a U.
No, I said a V.
No, you said a U.
I switched it to a V, I
Dude,
promise.
that's what I have.
Promise you said a U.
Oh,
I
and it's
swear to
not.
God.
I swear
It is.
to God. It's a V. Because like, I thought about it, I was like, it's gonna have the same like points on this side.
Pass the horizontal.
Does it pass the vertical line test?
Does not.
Yes.
Yes.
The vertical line test.
Yes.
No.
Yes,
Yeah,
it
yeah,
passes
yeah.
the vertical line
That's
test.
what horizontal, that.
Does it pass the horizontal
No,
line
no,
test?
it doesn't.
Does
No.
not.
So is it 1 to 1?
No.
No.
No, it is not.
What?
Are any of the absolute valuables gonna be 1 to 1? No, I don't think so. Good. Literally?
Say something nice to me. You never say anything.
You never did.
That's not true. Say it
This dude, bro.
That was back.
Alright, so that's all I got for you today. Okay? So, but I am giving you a mod, especially for those people that are missing something or have something to fix. Okay? Okay? That's what this time is for. This is not time to immediately go onto your cell phone and start snapping in IGA. Okay? Okay? So I believe, if I'm not mistaken, everybody has something that can be done.